In this video, we are going to solve systems of equations using the elimination method, and this is part 2. In these examples, we will be required to use multiplication to help us get our variables to be eliminated. So remember, we are looking for a pair of our variables to be opposites. We're asking ourselves, are your x's opposites or are your y's opposites? So in the previous video, we were able to answer yes. In this video, our examples are going to be no, they're not opposites. And so we're going to use multiplication to help us get our variables to be opposites and then go ahead and add the equations together to solve. So let's take a look at our first example. Here our equations are x minus 5y equals negative 8 and 2x plus 3y equals negative 3. When we look at our variables, our x's, x and 2x, those are not opposites. They don't make a zero pair. And negative 5y plus 3y also does not make a zero pair. So what are we going to do? We want to make sure we have to have a zero pair. So we need to actually multiply one or possibly both of the equations by something to create opposites. So I'm thinking about which variable do I want to multiply by. And if you have a variable where you can actually just do this with multiply just one equation, that's going to be easier than having to multiply both equations. So I'm looking at those x's and having a 1x and a 2x. I could multiply equation A by negative 2, and that would make my x's be negative 2x and positive 2x. So that's what we're going to do. We're going to multiply the first equation. Now we have to multiply the entire equation so that it stays equal, and we're going to get negative 2x plus 10y equals 16. So we're going to use our new equation A with the original equation B, and notice how now our x terms are opposite. So let's go ahead and add our equations together. Our x's make that zero pair. 10y plus 3y is 13y, and 16 plus negative 3 is 13. We're going to divide both sides by 13 and get y equals 1. So now we have our y part of our solution, our ordered pair. Let's go and find the x. You can use either equation. I'm going back to the original equation A. I'm going to plug in 1 for y and then solve for x. So x minus 5 equals negative 8. We're going to add 5 to both sides, and we get x equals negative 3. That means that when we check our work, we should be using equation B so that we can make sure it is the correct solution. You're plugging in negative 3 for x and 1 for y, and then simplifying that left-hand side. Negative 6 plus 3 does equal negative 3, so we have a true equation. Negative 3, 1 is the solution to our system. All right, example number 2. Here we have our system is 4x plus 2y equals negative 4 and 4x minus y equals 2. Now I'm going to look at my x's. I don't have opposites. My y's are not opposites. So we're going to need to use multiplication. So we don't have opposites. We need to use multiplication to get opposites. So which variable do I want to make opposites? Well, when you have the x's as 4x and 4x, they're the same. We can multiply one of those equations by negative 1 to get 4x and negative 4x. So let's do that. I'm going to choose to multiply my bottom equation, equation B, by negative 1. Remember, you need to do this to the entire equation. It's like a giant distributive property. So negative 1 times 4x is negative 4x. Negative 1 times negative y is a plus y. And negative 1 times 2 is negative 2. All right, so here are the system with the original equation A. We didn't do anything to that one. And then our new equation B. Let's go ahead and add our equations together. So in this case, our x's are going to be our zero pair, and we have 3y equals negative 6. We're going to divide both sides by 3 to get y equals negative 2. So now we have the y part of our solution. Let's go ahead and find x. We are going to pick either equation A or B, and then we're going to plug in -2 for y. So I chose equation B, which means I notice how I have that subtraction, and when I'm plugging in -2, it becomes 4x minus -2 equals 2. So let's change that minus -2 to plus, and then we're going to subtract 2 to both sides. 4x equals 0. You might notice something happening here. When we divide by 4, this does equal 0. So you can get 0 is okay to get for one of your variables. 0, -2 is our solution. So since I used equation B to help me find x, I'm going to use equation A to check my work. So I'm plugging in 0 for x, -2 for y, and simplifying to make sure it makes the equation true. So 0 plus -4 does equal -4, and we know we have the correct solution. That is the end of our video on solving systems of equations part 2, where we had to use multiplication to one of our equations to help us solve.